All right. Hello and welcome, everyone. It is June the 24th in 2025, and we're talking about snakes. We're talking about Python and Python libraries, specifically our Chainguard libraries for Python. And I'm glad to introduce my fellow DevRel engineer, Patrick Smyth, who is an expert in this whole Python ecosystem and knows a lot about it, way more than me. So I'm going to hand it over to him because he's going to not be able to confuse you as much as I would with the Python world. I did that last time on the Java side, and that webinar slash learning lab is actually online on the website. So if you can and interested in that ecosystem, you can digest about that and watch that on YouTube. But today we're going to listen in on Patrick. Please do ask your questions anytime on the chat. We'll be watching in the background, and I'll hand it over to you, Patrick, to introduce yourself and give us a good show.
Great, awesome. Yeah, we are talking about snakes. We're snake security today, so we got to secure those snakes. I was actually trying to come up with a name for a webinar and stuff, but all the good ones were chosen, snakes in the grass and all that kind of stuff. So, all right, so we're going to talk about Chainguard Libraries for Python today. Many of you hopefully are a little familiar with Chainguard, but we're going to talk a little bit about the company, what we do before we get into it. My name's Patrick Smyth. I'm a staff developer relations engineer at Chainguard. I'm from Queens, New York. I used to work with Columbia, James Webb, Six-Stored Pandas, and I'm one of those guys who loves to swim around in frozen lakes and stuff like that. I was just in a waterfall a couple of weeks ago, and last time I was in it, I broke my toe, but I didn't break anything this time, so that's good. So let's talk about Chainguard. What is Chainguard? Who is Chainguard? Chainguard is a very cool company I'm privileged to work for. We are best known for our Chainguard containers. I'll talk about those in a second. Our founders have done some very cool things. We have stuff like one of the creators of Kubernetes, creators of the Salsa project, set supply chain levels for software artifacts, Google distro lists. So we have security in our DNA, and we take our technology very seriously. We take our customers very seriously. So we huge number of customers have Chainguard powering their infrastructure, especially folks who are interested in doing FedRAMP, folks who are interested in working with the federal government, folks who are in sensitive industries, and folks who are technology providers, especially. What we're most famous for are Chainguard containers. And our Chainguard containers are tackling this difficult problem, which is, we have the vulnerabilities in terms of vulnerabilities in software, defects in software that can affect your application. There are known vulnerabilities and unknown vulnerabilities. And in terms of known vulnerabilities, these are vulnerabilities all listed in a database in the CVE system. And when you build, it's fine. You could probably we're developers here. We can usually avoid trying to get security issues into our software, especially with the help of all this modern ecosystem scanners. But what do you do when this foundation that you build on, which is your distro, your language runtimes, other utilities that are upstream of you, have vulnerabilities? And so we, with our Chainguard containers, we're tackling that problem. I personally call it my boss assigned me to fix Ubuntu problem. So that's the problem our Chainguard containers tackle. And we don't just patch up some distro that's upstream. We won't go all the way upstream, build from cutting edge repositories in our Chainguard Factory, and we build an entire distro, Chainguard OS, from the ground up to make everything secure. Then we move on to the language runtimes. Okay, so that's Chainguard containers. That's what we're most known for. But today, we're going to be talking about a new product from Chainguard. So Chainguard's introduced two new products in recent months, and that's our VMs. And the story there is a lot similar to our container images, but we're bringing it to the world of VMs and also to VM container hosts, especially. But today, we're going to be talking about a product I'm extremely excited about, and that is this project, Chainguard Libraries for Python. Okay, and I'm going to get into it, but because this is it's a product that deals with the Python ecosystem, goes kind of deep into different kinds of security, supply chain security. We're just kind of going to start from the beginning here. We're going to talk about some fundamentals. Bear with me if this is all stuff that's familiar to you. Maybe you'll hear a little bit that's new to you. but we'll be getting a little deeper into things as we go along. But I always think it's good to start from the beginning here. So what is a library? It's a building full of books. Well, it is, but when we use it in software, it has a more specific meaning. So when we talk about in Python specifically, we talk often, you'll hear different words that are used somewhat interchangeably, but they do have different meanings. So we talk about modules, which is basically just another Python file that you're importing. That's the most basic kind of code import you can bring into your other code. You could even just write two .py files, write a function in one, and import it in the other. Now you have a module, okay? So kind of the simplest unit of importing code. Then a little more complicated, you have a package. So package is a folder with one or more Python modules in it. It has that, you've maybe seen it, init.py file, and you can pull that in. The API to pulling in packages versus modules is pretty similar, import whatever, and you can bring that in. Okay, so these are words you'll hear tossed around: modules, packages. They have more of a technical definition. Libraries are more of a conceptual idea, okay? And we talk about libraries in many or most ecosystems. You'll hear about them in Python. And a library is essentially, it's an abstraction. It's any code that you're bringing into your own application code, okay? And in Python, we'll often use it mainly to mean libraries that are released formally, as projects. And we'll get into where we sort of get those now in a second. But want to just tackle this issue. I would say this is the main issue of this modern ecosystem of package managers, dependencies, libraries, importing. And this was the original AI. 20 years ago, thereabouts, in the 2000s, there was a lot of software development was either maybe you find some example code on the internet, you just stick it into your thing, but probably not even that. Code was often just written from scratch over and over again. And this idea of having libraries that are standardized to some extent, and you can pull them in to your language runtime and use all these different utilities, it really changed programming, accelerated everything. And that's why I kind of call it's like the original AI or whatever. But with all of this power of just pulling in this huge amount of code from somewhere else, it was kind of fine for a while because it was kind of a more simple world in 2007, 2008, 2009. That's around when PyPI started, which we'll talk about in a second, Python Package Index. And it was a simpler world. It was a much more trusting internet. And people weren't really using Python. It wasn't running in production in hospitals. It wasn't necessarily running on drones. It wasn't running in a surgical, operating theater or whatever. And these are all real use cases for Python in the modern world. Also handling people's sensitive data. So things have really changed. But this problem hasn't changed, which is this problem of pulling in the whole graph. Okay, and so when you pip install something, maybe many of us have pip installed something. If you're new to Python, maybe you've npm installed something or used Maven. Then when you pip install something, you don't just pull in that one library. You pull in all its dependencies, and then also transitive dependencies, so dependencies of dependencies. So you actually pull in a whole graph of software. And I think many of us understand that is true. We're sort of vaguely aware of it. But when you actually start thinking about it as a problem, that you're pulling in a lot of software that you're not even that aware of or only vaguely aware of, it becomes much more of an issue. When you sort of come to terms with that, you sort of realize that actually pulling in this whole graph of software every time you pip install can cause a lot of problems. So another component of this whole ecosystem is the package index, okay? And in Python, we have an amazing piece of infrastructure called PyPI. They get mad, by the way, if you say PyPI. So, it's tempting to say it's spelled PYPI. It's tempting to say PyPI, but you want to say PyPI. It's the Python pack because there's a compiler or an alternative interpreter for Python that's called PyPI. But it's a very modern piece of infrastructure, the Python package index. This is, by the way, this is a Monty Python GIF here. Python was originally named after Monty Python. It was a British comedy from the 90s, and a lot of Python naming is actually based on this show. So if you've ever heard PyPI, Python Package Index, being referred to as the cheese shop, then it comes from this skit from Python, okay, from Monty Python. So PyPI it's a very modern piece of infrastructure. There's some amazing people working on it. It has over 630,000 projects. So that's kind of how they track, you know, it doesn't count multiple versions. If it's a project, it could have multiple versions. So 630,000 unique projects, almost 27, about 27 terabytes of information is hosted on there, and literally billions of downloads per day, which is crazy. That's a B with a billions. Okay, so this is and it's based on in 2018, I believe they really modernized a lot of PyPI. They use a project called Warehouse. And so, you know, we're very lucky to have PyPI as a piece of infrastructure. It's an open bazaar where anyone can upload anything to PyPI, and PyPI will serve it to users, and they will do it at scale. And to my knowledge, PyPI itself, the platform that distributes the software, has never experienced a hack. Now, there's a big caveat. There's a big but coming. The big but is that it's a much more hostile environment these days for not just Python, not just PyPI, actually all of software development. And that is because supply chain attacks are on the rise. They're basically doubling year over year. And they're quickly becoming kind of the main way that large scale attacks happen. We'll actually do a little dig into one of these that happened in December. By the way, this is from Hamlet, from the movie from the year 2000, which is actually a pretty fun version of Hamlet where people have like guns and stuff like that. But the, you know, something set rotten in the state of Denmark in software development. So let's just run through. Now this is the, I don't know if any of you guys have seen the meme calendar before. So I got a meme calendar for you, and we're just gonna run through 2025, okay? And we'll do a hack a month, okay? So January. What happened in January? There was a cross-index attack that attacked both NPM and PyPI. This is actually a very widespread attack. In February, and I put a Napster logo here just because I was being weird, and I'm nostalgic for the Napster logo, but there's a music service called Deezer. There was this shady command and control library that was uploaded that had a lot of downloads that extracted files from Deezer, but probably did a bunch of other shady nefarious stuff. March, there were a whole suite of libraries pretending to be time utilities that would steal your cloud API credentials. In April, there was an attack called Confused Composer, because gcloud allows for custom PyPI libraries to be run with its environment, and people use that for privilege escalation. So it was an attack called Confused Composer. I have a little picture of Amadeus Mozart there. In May, just last month, we had a pretty wide-scale attack that used Gmail to exfiltrate cloud credentials. And in June, actually, there's actually much worse. I created this deck a couple of weeks ago. This is from a project called GlueStack that had a bunch of bad releases. That happened early in June, but actually there's this larger attack I haven't dug into called Chimera extensions. That's going to be the big attack from June. But the upshot of all this is, and actually I could have chosen 2 or even in some cases 3 major attacks for any of these months. And my point is that this ecosystem is under constant threat. And PyPI is doing the best they can. They actually have implemented a lot of great mitigations in some ways. But it's this environment of constant threat where typo squatting, repo squatting, slop squatting, where people are using AI to do typo squatting, and on these like targeted spear phishing, whatever attacks are just constant in this ecosystem right now, unfortunately. All right, so taking a little step back, we're just going to talk about the supply chain and so what is the anatomy of a supply chain attack? We say software supply chain, right? It's an analogy with the physical supply chain. Physical supply chain it takes raw materials, and over many steps, many actors in sort of a system, a complicated modern system, it transforms those raw materials into a finished product, okay? And in software, we also talk about the supply chain. It's sort of based on this as a metaphor, but it's very similar. We have many actors, many steps, and many different software inputs, and those combine to produce finished outputs in the form of various software artifacts, okay? A wrinkle of the software supply chain is that many or most actors occupy 2 positions in the supply chain, sort of an upstream and a downstream. So folks on this call, probably you're involved in creating software in some way. If not, good for you. and so you have users that you're responsible for, and you don't want to introduce security flaws to your users. However, you also ingest software from upstream in the form of language runtimes, distros, libraries, container images, whatever. And all of those, if there are vulnerabilities in those upstream projects, you can then very easily, and it's the default, pass them on to your users, okay? And you don't want that. So there's a big responsibility there. Now, in the world of libraries and in the world of pip install and Python projects, but this also applies to other kinds of software builds. There are actually, unfortunately, many moments or points in the build and distribution process where an attacker can intervene to insert or inject malware into the build that gets passed to users, okay? So the one that people think about is source, right? So if you think, oh, supply chain attack or like an attack on a project, you probably kind of think, oh, maybe somehow the attacker manipulated the source, maybe did some social engineering, maybe did something else. The source got manipulated. That's very much the minority of cases. It does happen. It can happen. It's definitely the minority of cases. Because eyes are on source very frequently, okay? And our research in this area shows that it actually tends to be these later stages where most of these attacks occur. So where does this stuff happen? In the build process, an attacker can intervene, and so then there will be a disjunct between the source and the end artifact if the build process is compromised. In the distribution process, so for example, the releases page, in the movement from any of these stages, so from source ingestion to moving to build, to moving to distribution, to moving from distribution to from releases page to customers, those are all those points of movement are also points where an attacker can intervene. And unfortunately, there's also the recursive problem. So because all these projects use dependencies themselves, all these points of attack apply to anything they have upstream of them. So there's a recursive project. So if a downstream project uses an upstream project, that upstream project has its distribution compromised. Now everyone downstream of them may be compromised, okay? Then there's even stuff like typo squatting and stuff like that kind of comes after the fact. So there's a whole bunch of top points where an attacker can intervene. And this, we have found, is where most attacks happen. Now, this is where I'm kind of going to introduce Chainguard Libraries, okay? So this is something that we've built, and the fundamental value proposition of Chainguard Libraries is that we go to, GitHub repositories, wherever source can be found. We find the source, the original source for a project. We take that source and we securely ingest it into our Chainguard Factory. I'm going to talk about our factory in a second. And then we build it securely within our factory. And then we place it onto our own Chainguard index for your use as customers, okay? So what advantages does that have? So the fundamental value proposition is that since we take the source, anything following manipulation of the source, so we take source as is, but then anything in the build, CI/CD, distribution, or a dependency pulling, or in movement from any of those stages is now secured in our own factory, okay? So we'll talk a little bit about the factory and its operational security and so on in a second. One caveat here, this slide was just a very beautiful slide. It was created by our marketing department. If it was me, I'm an engineer, I would probably have made this source red, just like it was over here, right? Because the way we do it is, if the source has been compromised, we do pull in that source. So that's one caveat here. However, that's generally not where most of these supply chain attacks happen. So depending on how you measure it, it could be that we would prevent, from our research, 92 or 98% of attacks, okay? Let's talk a little bit about our Chainguard Factory. This is an extended metaphor that we've developed at Chainguard. And the idea is there's a way we conceptualize of our build system our modern build system that we've created. And essentially what this is it's a build system that takes various inputs, so tool chains, source code, language runtimes, other utilities, and orchestrations, and uses all of those inputs in this complex and sort of bleeding edge system to produce software artifacts. Okay. We have amazing automations. We have an amazing team of folks who A, create those automations, B, step in to fix and remediate issues when they arise. And we also are kind of AI accelerated now, so that often our PRs are sort of like half written for or fully written for our folks. So this is and we also, this year we love testing everything. Because we love automation and we love testing, and we've just this last year moved to a whole system created from scratch. We were burning huge amounts of money GitHub Actions. Now we burn huge amounts of money in our own on-prem build system. So this is a system we're very proud of. It powers all of our products. Okay, and the other thing I just want to mention is the operational security for the Chainguard Factory is I would say exemplary. And if you check out the SALSA project, so software levels for supply chain levels for software artifacts, we are SALSA 2 compliant, working towards SALSA 3, which is extremely strict requirement around signing all artifacts and checking signatures as you move any artifact around within the factory. Okay, and there's a whole lot of other things we do to secure the Chainguard Factory. Okay. I want to talk a bit about, so I feel like some of this is a little abstract unless you dig into a specific attack, a specific compromise that has happened. Okay, so one that is worth highlighting, we talked about one for every month this year, so 6. I'm looking forward to seeing what cool supply chain attacks we have in July. But this is the really big one. So we went back to January, but what about December? December 2024, Ultralytics YOLO. So this is a YOLO, it's a fast object detection algorithm. Ultralytics has a popular implementation of it. It's a Python library. It's available on PyPI. And in December, their GitHub Actions workflow was unfortunately compromised, and the attacker was able to distribute a compromised version of Ultralytics YOLO with malware, and the malware actually ran crypto mining software, which is not exactly what you want running on your production systems. And then they actually were able to push a second. They actually then leveraged that to capture a long-lived API token, and they actually pushed an additional bad version. And something like 10% of cloud environments have Ultralytics loaded in there. So the scope of this attack is actually fairly serious. Okay, so this is just an example of one attack. There's also another one I won't get into for time reasons, but if you check out the PyTorch attack that happened in 2022, it was a dependency confusion attack. It also had some fairly serious ramifications. Okay, so these are the types of attacks that we protect against as Chainguard Libraries. Okay, and also those 6 attack ones you heard from this year, that's also the kind of stuff we protect against. So just want to talk about a few little caveats before we get into some fun demo stuff. Okay, one is in Python uses some libraries are native Python. They only have Python. Other libraries, they use they use binaries that are available on the system. Okay. In those cases where there are binaries linked on the system, so if you're using Chainguard Libraries right now, this may be liable to change. This is a very new product, but right now you need to be using Linux, and you need to be using it using a glibc implementation 2.9 or higher. Okay, and right now we also only support Arch and ARM. Correct me if I think that's ARM 64 and Arch 64 architectures. And then finally, the other thing I wanted to talk about, I'm not going to get too deep into this, but we're doing another cool thing. You can check out a blog post for a little more detail on this, but we're doing another cool thing where there's such a thing as vendor dependencies. So a lot of libraries will, instead of formalizing having other projects as an upstream, they'll just grab files and stick them into the project folder. So those are dependencies, but they don't get registered by scanners. They don't really come into the proper scanning and remediation ecosystem. So we actually also have been externalizing those and formalizing them as projects. So we're removing this dark matter and unvendoring the dependencies, sort of making them formal dependencies of projects, which I think is a cool part of Chainguard Libraries. But I just wanted to throw that out there as something that we're doing with this project. So I think it's demo time. What we're going to do is, and maybe we'll pause for a second just in case Manfred has any questions or anything that I can address, just because we're switching gears here. So I'll listen for that. But what we're going to be doing is, one, we're going to take a look at a Flask project. So Flask is a very minimal web framework for Python. We're going to take a look at a Flask project, pretty standard. And I actually kind of deliberately reused a project that we've used for some other demos because I was like, okay, I don't want to manipulate this demo too much, okay? And I want to show you how that it's not, you know, whatever. There's some wrinkles, but it's fairly straightforward to switch over in some ways to Chainguard Libraries. And then we're going to be showing you how we can use Chainguard Libraries in that project, okay? So you can actually use all Chainguard Libraries for all the dependencies that this project is based on. And we'll also use an internal tool just to check the validity of those dependencies, okay? One thing I'm sort of skipping over here a little bit, and I'm going to direct you to Manfred's amazing talk last month on Chainguard Libraries for Java. He went into a little more detail on setting up the global configuration or the repository manager configuration so, you know, just to take a step back, repository manager is a piece of software that can be used at your organization to control how and from where you're getting your dependencies, okay? So what you probably may have heard of JFrog Artifactory, that's one of the biggest ones, but there's also, you know, there's Cloud Smyth, there's Nexus, and a whole bunch of other ones, okay? So we will not be showing how to set up your Artifactory instance. This demo kind of assumes that you have that someone at your organization or you have set up a say, for example, Artifactory. I'll be using Artifactory here, but set up a repository manager to ingest from the Chainguard Libraries for Python index, with a fallback to PyPI, because we do recommend that right now, because our coverage isn't 100%. And then I will be showing you the tool configuration part, so that you can pull something from your repository manager in and use it locally, okay? Okay, I'm not hearing any questions, so hopefully everything's still working. I'm just going to switch back. Yeah, everything's still working. Okay, so let's, if you take a minute now, you can head to this page that is linked here. So there's the Go links link here that you're seeing on your screen. And that will bring you to our Chainguard Academy. So that's our documentation and you know, kind of community site for our, you know, to learn about Chainguard's technical products. And if you take a look at the demo section here, okay, you also can find the deck and so on if you're interested in that later. If you go to the link in the demo, let's go here. And you will hit a GitHub repository, okay, and that is our that is going to be our. I just have it open already here. So we're going to be to clone this repository. We're going to switch to a particular branch, okay, and then we're going to run this code just as usual, okay, as you would with, you know, pulling from PyPI. Then we'll add Chainguard Libraries, okay. We'll do that two different ways. And I just kind of want to give you a sense of how this would work in practice. So let's go ahead and clone this. Okay, I'm going to pull up the command line. I'm going to my source folder where I stick a lot of random stuff that I clone. Git clone. Okay, so you should have cloned this CG migration project, okay? And fundamentally, this is an example project that is a Flask. We'll open up the application file in 1 second. This is taking up a little much space, so I'm gonna quickly shorten this prompt, okay? I use Z shell and it can get a little verbose in the prompt, okay? So I'm getting the classic $ here. And then so what we're going to do is, first we'll create a virtual environment. Actually, let's just take a look at the project first, okay? So we have a couple of files here. So these are the files in the folder. We have a Docker file that we'll use at the end here. So that is to containerize the application. Oh, I'm sorry, I didn't switch the branch. Git switch libraries. Okay. And now we've switched the branch. So now we should see a Docker file, an application file, a Python file for our Flask application. There's a README, and you have a requirements.txt. The requirements.txt, it just has two dependencies. It has Flask and G-Unicorn or Unicorn, standing for Green Unicorn. That's a server software, okay? These, you might be used to seeing these pinned, okay? Because this is a project that I don't want to have to go in and update every week. I haven't pinned things, but yeah, pin your dependencies in production. That is my advice, okay? So you would have an equals version here, okay? But for now, we're just pulling the latest by just having these bare dependencies in the requirements.txt. And then quickly looking at the Flask application, it's fairly straightforward. It has Flask allows you to have roots, so root a specific URL to some output, and all we're doing is we have the index root, and it shows a little message saying Linky is best. Linky is our little mascot, and a bunch of octopus emojis. Okay, so it's a fairly straightforward application that we can run. So we're going to run this application now. We're going to first create a virtual environment. So we'll do Python -m venv for virtual environment. And then we'll just call it venv, okay? So we're using venv twice here. Give it a second to create the venv. If you can ls now, we can see that it's created a venv folder. We can now change, we can sort of activate the virtual environment. So we do source venv bin activate. Okay, and you've seen my prompt change to show that now we have the virtual environment loaded. And then now we're going to install our dependencies and then run the application. Right now, we're doing it from just from PyPI, right? We haven't made any changes yet to the project. So by default, I haven't configured this workstation at all to use Chainguard Libraries. Okay, so we're just going to be pulling from PyPI as is the default. Pip install our requirements .txt. Okay, give that a second. Hopefully that will have allowed us to run our, so now we're going to do Python app.py to run our, and then I'm going to open this, so in the browser. So our application is now running. We installed our requirements, Flask and G-Unicorn. We did Python app.py to run our script. And now we are opening a browser. And I'm going to 0000 colon, I think it's 5,000. Yep. And then, so it's Linky is best. It's just a simple application. It runs this, it hosts this one page, okay? So this is been installed normally. So we have a tool at Chainguard. We're working now to open source this tool. So hopefully you should have access to this sooner rather than later. It's called libCheck, and it tells you if how much of, say, a virtual environment, or if you point it at a specific Python wheel or some other software artifact, it'll tell you how much of it has been built by Chainguard, okay? So we're going to do libCheck, and it's going to say nothing right now. libCheck parent chainguard.edu. So that is the account that we have access to that has the entitlement, okay? So that would probably be the name of your organization if you're using Chainguard Libraries. And then we point it at the venv that we created. And it should say, yep. So nothing, verification coverage, 0%. So I pointed it at the venv. I said, how much of this is Chainguard? 0%. That's exactly what we anticipated, okay? I'm gonna delete that virtual environment. We're gonna start over again. So rm venv. Now we're going to make some changes and we're gonna run it with Chainguard Libraries for Python, okay? I'm gonna do deactivate. Okay, and now we're back to our prompt. We've deactivated it. We deleted that virtual environment. Now what we're going to do is I'm going to go to my pip.conf, okay? And I'm going to use Emacs because I'm a weirdo, okay? But you can use VS Code. You know, if you do type code or whatever, do that. And so E is for Emacs in my case, tilde /.pip. and then it's at pip.conf. Now, your machine may have this folder already. It may not. So in a case where you wanted to make these changes and you didn't have the .pip config folder, you just create it. So mkdir -p just in case pip in your home folder, and then we want to create a file called pip.conf. Okay, so it's blank. So I'm editing it, and now I'm gonna add this global, and then that means change everything on this workstation for pip when we use pip, and we're going to use and you know, you're just going to see I'm going to cancel this key after this talk, but we now have the Artifactory URL. So this URL I just got from going into Artifactory and saying, you know, set me up, okay, and it gave me this link, and then I'm going to set it as the index URL. And so now this should affect the entire workstation. So anytime I use pip, it should now be using Artifactory. And what we do on there in Artifactory is we've set it up to use Chainguard Libraries first, and then if the library isn't found in Chainguard Libraries, because we haven't built everything yet. We're working toward it, but we haven't built everything yet. Then it'll fall back to PyPI. Okay. So and then we're going to do now do the same thing we did before, but where we've changed our configuration file. Okay. So let's do pip install. Oh, sorry, we have to create the virtual environment. Python venv. Okay, we're creating a fresh virtual environment. We deleted the old one. We're going to activate it. Okay, just like I did before. And now we're going to pip install our requirements.txt. Okay, and now this should be pulling from Chainguard. Okay, takes a minute. Now we have a nice virtual environment here. We're going to use libCheck again. And then we'll just use the same as before, same command. And now it's 81%. Now, why is it 81% and not 100%? There are certain files in the virtual environment when it gets created that are you know, not from Chainguard. Okay, this is kind of something we're going to be working on and coming up with some best practices around. But for now, the dependencies we're using, Flask and Flask's dependency, so Verkzoig, it's dangerous, etc. They are all Chainguard, and then you know, so is gunicorn. Okay, we'll just run the application, Python app.py, and just, you know, guys, whatever. I want to show you that it actually works. It should be the same as before. Yep. So we're hosting. So now we're using libraries that have been built within the Chainguard Factory. Okay, not by a whole bunch of different upstream providers that are somewhat anonymous, but actually you now are only having to, in a sort of a supply chain sense, trust Chainguard. All right. So we're going to do this one other way. All right. So, and this is Chainguard, and we love containers. We love containerizing things. We think that is how to put things into production. Okay. Right now, as what I've shown you, it's just running it bare on the machine. So we are going to containerize this application. Right now, if I build the container using the Docker file we have here, then which uses a multi-stage build for Chainguard images and winds up with a hardened version. Then if we use it right now, it will use PyPI. Okay, but because it's not the build process doesn't look at the global workstation. Okay. However, one fairly straightforward way you can do this, there's a couple of different ways that you can do this, but one fairly straightforward way is to change the requirements.txt file. Okay, so if I edit the requirements.txt file, I'm just going to add that URL, the link here. So we're actually just in the requirements.txt changing the index URL to draw from Artifactory. Okay, and we're leaving everything else the same. And then we're going to do Docker build. Let me make sure I saved that file. Yep. Docker build in this folder, and we're going to tag it. I'll call it libraries Flask. Okay. I think that's all we need. And it should be building. You'll see it installing from Chainguard. You could actually, you know, I did this earlier and I made it print everything out just to make sure that everything was pulling from Chainguard. Yeah, you'll see this is the part where it's installing dependencies. And so when we're done with this, we should have a containerized version of this application. Yeah, success. And then we're going to run it. So we're going to do Docker run interactively. And then we have to set the port explicitly. It's going to be 8,000 in this case. 1, 2, 3, 8, 1, 2, 3. And then because it's using G Unicorn. And then we'll called it. We called it libraries Flask. Okay. So we're running it. It should be at port 8,000. We're going to go take a look. 0.0.0.0:8 1 2 3, and there it is. So that's the containerized version of the application. Okay, so that's two fairly simple ways of adding it. There are other ways that are documented on our Chainguard Academy for various tools, and also, you know, not just for pip, obviously, also for UV, which if you haven't checked out yet, that's Astral's this company Astral has thrown their hat into the ring with a very modern package manager for Python. Definitely something to check out this year if you haven't already. And Poetry, of course. So you can take a look at that. We have fairly extensive documentation. And if you have any issues with it, you can open an issue on Chainguard on our Chainguard Academy or drop us a line. And now I'm hoping we have a little Q&A. So let me go back to our thing. If you want to check out Chainguard Libraries, you know, I mean, you can really you go to chainguard.dev/libraries is the easiest way, or Google Chainguard Libraries, or you can go to this nice QR code or take a screenshot, look at it later, and you know, time for Q&A. And I have my LinkedIn there on the top right if you want to use your QR code to connect with me on LinkedIn. So hopefully we have a few questions, and I'll leave Linky up here while we talk.
Awesome, Patrick. Yeah, we did have a few questions that showed up. I answered most of them, but I think it's worth discussing them anyway. So one thing that came up is for the repo manager, the setup. I just mentioned that it's very similar to what we did in Python. Like what we did in the Java world. It's just a different UI, and the terms are different, but it's just a URL. You add on your username and passwords that you get with chain control and hook it all up. So we didn't demo that as well today. So that should be pretty easy, and we have that documented in the version as well.
Yeah, we have that documentation set up, and I'd also just say if you're not using a repository manager, it's a good class of software to add to your organization, just because it can help avoid some issues like dependency confusion attacks, for example. And if the PyTorch project had been using a repository manager like 3 years ago when they had that attack in 2022, the dependency confusion attack, it would have been a lot harder to pull off an attack like that. So it's also a good thing to add to your organization stack.
Yeah, that's a good plug. It also provides a target for any internal libraries we write. Like at your organization, if you write any libraries, you can publish them there, and then other teams in your organization can consume them.
Absolutely.
The other thing I wanted to also talk about quickly is that the processor architecture and Linux stuff. So we support ARM64 and x86-64.
That's what I don't know. I wasn't.
Yeah, no, it's clarified.
I was being enumerate.
And for the glibc, we're working towards getting 2.2.8 support. That's coming soon. Then we basically support pretty much every Linux distribution that isn't so old that you're gonna go crazy, right? Like, I mean, like ultimately it's all good and nice to use libraries, and like that provides a lot of security. But if you then use a Linux distribution that's so old and full of holes of like other security issues, it doesn't really help. So you should be probably paying attention, and ideally use Chainguard containers, right? So then that's all sorted out. So you're good with that. The libCheck tool you mentioned, it's going to be open source soon, hopefully. So that's going to be really cool. In your demo, you showed the 82%. What's also interesting with that tool is you can do detailed, and then you see exactly the list of like the libraries that came from Chainguard and not, and a lot more details. Once we open source that tool specifically, we'll probably do a demo and show you all, maybe even in another learning lab. So that should be cool. Now let's see what else.
Yeah, I'm looking forward to that getting open source.
Yeah, that should be interesting.
Anything else to tackle?
Yeah, so there was a question about the slides, and yes, there is the slides available actually on that URL.
Yes, I've uploaded them now to where we did the demo. We have a page on a Chainguard Academy now for this learning lab. And if you scroll all the way to the bottom, we have this slide deck as a PDF. If you're interested in it as a, as Google Slides, we're trying to share that too. So just drop us a line. I don't mind. We can share it. But yeah, we have the PDF here with all the memes and everything like that. And if you want to use memes or whatever in your own presentation, then go for it. Memes are meant to be shared. Okay.
Yeah, fair enough. And also, we will add the recording of the video to this post in the future. So if any of your colleagues that missed the learning lab today want to have a look, then they can see the demo, and that's been actually very awesome. Patrick, thank you so much for that. It's been great. Bodo is also asking, is it possible to see CVEs? Maybe you want to clarify what you mean by that.
Yeah, I could kind of tackle that a little bit. So if you're using, say, for example, Grype, you can look at file systems as well as. So the simplest way to look at it would be Grype venv, and just scan the virtual environment that we generated, and it would actually scan it just fine, like it would scan. Now, we're looking at some value adds in this area. I don't want to necessarily say too much right now, but as of right now, we are mostly focused. The product as it exists is mostly focused on the supply chain issues. But we love remediating CVEs at Chainguard, so we're definitely thinking about it. But I won't make any promises. Okay. But yeah, it's scanning. I don't know. It seems to be taking a long time for some reason, maybe because it's a file system. But eventually, it should finish and tell me. So you can, in theory, you can look at this. And also, we built an image with the application, so we could scan the image as usual. Okay, but we're not, as it is right now, we're not explicitly remediating CVEs. What we're trying to do is mitigate this supply chain risk in terms of the build, distribution, and the dependency graph. Okay. Yeah, I don't know why it's not finishing, but in theory, this should work. But
might be an internet.
There it is. It did
look
finish.
at that.
Yeah, and it's not too bad actually. We have we have one medium, I think, in Python right now. So we got a warning. Oh, no vulnerabilities. That's awesome.
That's because you're using the Chainguard container, probably.
Yeah. I just did the bare venv, but there might have been an issue with that. Let me just quickly run it on the libraries. Flask, just to see what happened. I'm curious anyway, to see what comes up. Yeah. So because we use contain, and now this is not libraries that's doing this, okay? Just to be clear, so if you sign up for libraries, but because I built with Chainguard Containers, we only have one CVE. Currently, there is one, I think it's medium CVE that I saw earlier today in our Python image. Often, if you scan it, it'll be 0 CVEs, and I would expect this to be done. It's a medium, so we're guaranteed by our contractual obligations to get rid of this within 2 weeks, so you won't see it for very long. My guess would be you're not going to see this tomorrow. So.